This is a Ventra Pro video showing how to wire up sensors on a Ventra Pro install. We're going to just discuss some of the terminating wires and how to do that correctly. So for the first example we're going to do is a temp sensor. I've got one here for, I'm going to terminate it on analog input 1. The terminals designated on the interconnect board start with A in 1, which would be analog input 1. Then it shows a ground GND and then a plus 12 volt. So some devices need a excitation voltage of 12 volts DC to supply to it. In this case, temp sensor is just resistive. So in this case, I've just got this. I'm going to go back about 5 inches or more on my jacket, and I've just scored around that a little bit. And as I've gotten that scored, not all the way through, then you can generally just get it to come apart, and we're going to want to hang on to the drain wire, this bare one. That one's going to terminate to our ground bar up here. In the case of some of the other versions of the Ventra Pro, this bracket will be hanging over this way and would still give you that ground bar. The other option is not having that at all, in which case these could be tied together and terminated on the green, the earth ground connection on the power coming in, because that all terminates to the same place. So I'm leaving it long enough so I can terminate here and still have my wires reach down to where I'm going to be at. The foil has to come off the wire, so we need to do that. So we can snip that with our cutter. And then using the appropriate stripper, we'd strip these. I've already got these stripped about 1/4 inch to 5/16, so enough to go into the terminals. So again, so on this case, since we're starting with our analog in 1, a lot of times we'll do red and then black. Although in this case, with a resistive device like this, it's not really going to matter. We'll stick those in, hold them in place, get our screwdriver, and we'll tighten up those connections. And then we'll also make sure that connection is made up to the ground bus up here. And we can tighten that up as well. Probably eliminate a bunch of these at one time rather than just one, but the bus will work regardless. So now my temp sensor is suspended from there. With all of these, then the next temp sensor, we'd skip a spot because we wouldn't be using the plus 12. If we had another temp sensor, it would be the spots number 4 and 5 where they would go. With a device like a static pressure sensor or a sensor, they would use these first 2 spots. The analog in would be the actual output from the sensor. The common or ground connection would be here, excitation or a plus 12 red wire in the case of our humidity sensors would go into that 3rd spot. So that's an analog input into a digital input. It's the same thing. We could use, sometimes our sensors only have no shield, but our field wiring definitely should be shielded. So the shield should all terminate at the controller, and we'd want to hook them up the same way. With a 3-wire connection, for instance, with a humidity sensor, the green would be the analog in 1, the red would be the plus 12, the black would be the common or ground, GND on the board. The same thing would be true for this particular type of water meter sensor for certain Badger water meters. If you're using one of these, the digital in would be the green, plus 12 would be red, and the ground would be black.